All right, so in this quick video, I'm going to go over how it is that you can build a RAG system using FedRAG and then fine tune both the generator and the retriever. And we're going to do all this using the HuggingFace Extra. And just in case if you're following along this video in a Google Colab, just want to make mention of this note here that says you have to supply, in addition to the HF token, HuggingFace that is, a weights and biases API key as well. And you'll also need to change the runtime to a T4 GPU. We are going to fine tune a sentence transformer as well as a pre-trained model in this video. Okay, so I'm going to skip this installation of FedRAG because I already have this installed, and we'll go straight to the next section, which is the beginning of building our RAG system. So the RAG system comprises of a knowledge store, a retriever, as well as the LLM generator. In this part, we'll go over building the knowledge store and defining the retriever, which allows us then to populate the knowledge store with some knowledge. Okay, so we're going to use an in-memory knowledge store, and for the retriever, we're going to use the HuggingFace Sentence Transformer Retriever, which allows us to use any embedding model that is available as a sentence transformer on HuggingFace as our retriever. So in this case, we are using Dragon Plus, which is a dual encoder. You've got a query and a context encoder, and we're not going to load it at init. So I'm just going to leave that as false. So now with those things things constructed, let's move on to adding some knowledge to our in-memory knowledge store. And this is just a sample, a very small sample, I think only 13 chunks here. That's coming from the December 2021, Wikipedia dump. And yeah, so you've got, these are essentially just JSON blurbs. You've got a title, section, and text of the article, and you've got 13 such entries. And what we'll do is we will take these text chunks and we'll create what's called a knowledge node within FedRAG. And right now we do have essentially in the future plans to take on nodes of different type, but this video will be on text type of nodes. And so let's import the knowledge node and node type, and essentially we're just going to take this JSON entry and we're going to create some text, which is just a combination of the title, section, and text as follows. And that will be the text content for each of the nodes that will populate into the knowledge store. So if I go ahead and run that, oh, sorry, you also see that with the retriever, we can encode the context. And this, again, will use the sentence transformer, and it will make that batch call. You can see here we're passing a batch of text strings to get encoded. And then this next little bit will actually create the knowledge nodes, and we'll have a list of knowledge nodes at the end of this. Okay, that's done. And if you see here, you've got the embedding, node ID, and if I skip all the way down, you can see there's a node type, which is text, and then the text content itself. And now we've got our knowledge nodes. Let's add some knowledge to the knowledge store. And for this, we could just do a load nodes. And once that's done, you can see the count. We've got 13 nodes within our knowledge store. Okay, so we've got the knowledge store, we've got the retriever defined. Let's define the LLM generator. Again, because we're using the HuggingFace Extra, we've got a abstraction called HF pre-trained model generator, which enables you to use any HuggingFace pre-trained model available on HuggingFace Hub. You can define the generation config by referring to the model cards or the model files with generation config JSON, and specify the parameters accordingly. And we're going to use Qwen2.5-0.5B for this video. And if we do that, again, we're not loading it at init. It's a lazy load. It will, whenever we need it, we'll load it for the first time. Okay, now that we've got all the components of our RAG system defined, we can now assemble our RAG system. And for FedRAG, it's this RAG system class, and we also need this RAG config. Right now, you can just specify top K. As we build out this library a bit more, we will allow for some more parameters. But defining a RAG system is super easy. You just use all those three things that we talked about before: the knowledge store, the generator, retriever, and then your config. And to test out the query, so pure inference right now, who is James Cook? If I just go back to the knowledge text chunks, there's an article or snippet of an article here on James Cook. So I'm just going to query who's James Cook. And if we print the response, we'll see a response as follows. All right, moving on to RAG fine-tuning. So that was RAG inference. In this section, we're going to fine-tune that RAG system. And to do so, we're going to use two classes, a retriever trainer and a generator trainer. And as the name suggests, we'll use them to train the retriever and generator respectively. While I should also note that these two models will be trained independently, but even though they are trained independently, the process in which doing so is standardized. And part of that process, the first step is defining your trained data set. And for now, within FedRAG, the way that you define your trained data set is essentially a set of examples of query response pairs. So this is some Q&A data from the Common Sense benchmark. And again, super toyish. Essentially, the goal here is to establish a pipeline and demonstrate how it is that you can use FedRAG to build a RAG system and then fine-tune it. So let's define our trained data set. And here in this section, we'll go over retriever fine-tuning, which the short acronym here is LSR, which stands for LM-Supervised Retriever Fine-Tuning. This was proposed in a paper called RADIT. Actually, it was another paper, but yes, here, in this paper here, replug. And if you want more details on how you can do retriever fine-tuning with LSR, please refer to official docs. In the tutorials there, we've got one for LSR. And now we can do some retriever fine-tuning. So let's use a trainer object, which is HuggingFace trainer for LSR. And this trainer object will take three things: the RAG system, the training data set, and optionally a training argument. And because we're using HuggingFace, this is essentially a training arguments class that you can pass. And one thing I should note about the implementation, this trainer essentially is sort of a wrapper around a sentence transformer trainer. And this is a custom one that performs the LSR training. So we've added in FedRAG the LSR loss, and this HuggingFace trainer for LSR utilizes that loss. Okay, so you could see the underlying trainer object that this retriever trainer is going to use, and it is this LSR sentence transformer trainer. And we can just train using this method train. Again, very toyish, and you see this loss here, which doesn't mean anything outside of we got the pipe set and water flowing through it. Okay, and in the next section, we'll go over generator fine-tuning. And similar to the process for retriever fine-tuning, we'll make use of a trainer object. And in this case, we'll use HuggingFace trainer for RALT. This is a generator trainer, right? So we're training the LLM now. And for RALT, essentially what we're doing here is creating instruction fine-tuning examples that contain retrieved context for each query response pair. And again, for more information on this, refer to our tutorials where you can see the write-up on this. And again, this was also proposed in the RADIT paper. Okay, so if we just execute this, we can again see the raw trainer object. It's a trainer rather than a sentence transformer trainer. And if we hit generator train.train, It should complete soon, and we can see a loss that probably doesn't, again, mean much, but there you have it. That's how you set up the pipes for building a RAG system and then performing retriever and generator fine-tuning.